Okay, three dimensions. The first day we talked about 0 and 1 dimensions, a point, lines, different types of lines. Yesterday was 2 dimensions, which are planes. And now 3 dimensions, we're not going to get real deep into 3 dimensions yet. We will later on this year. For now, you just need to know what a three-dimensional shape is called. All right, and a three-dimensional shape is generically referred to as a solid shape. All right. Two-dimensional shape really doesn't have any height to it. It's like a piece of paper. It's real thin. It's flat. It's not really called a solid. A three-dimensional shape would be, like this eraser I keep using. It's a solid piece of matter. It has length, width, and height. All right. Some other terms you might hear would be a term to describe, say, a shape like this. So you have, see if I can draw this real nice and pretty. Probably not, but that's not bad. All right, that's my triangular prism. A triangular prism has a triangle for a base, triangle on the bottom, which is a two-dimensional shape, and then it rises up off of the slate and has height, and that's what makes it a prism. So it's really any two-dimensional shape that you give height to, it becomes a prism. So you could start off with, say, a square and give that height, and as soon as you give that height, that two-dimensional square is now a three-dimensional square prism or rectangular prism. All right, you can do that with a circle. Circle is a two-dimensional shape. As soon as you give it height, now it's a circular prism, which has a fancy name called a cylinder, but it's all the basic concept here. You take any two-dimensional shape and you rise it up off the slate, you give it height, you give it a third dimension, and it's called a prism. So you have solids and you have prisms, and those are your three-dimensional shapes. Now you can manipulate those and do things with those, but that's later on in the year. For now, you just need to know what a solid is and what a prism is, and it's the same thing. It's a three-dimensional shape. Okay, good. All right, the last things that you need to know this week for this section are a couple more definitions. So instead of just telling you what the shape is and what the definition is, I'm going to go kind of backwards here on this one, and I'm going to work through the definition, and then you're going to figure out what the shape is. So there's a big word in this definition, and it's called equidistant. Oops. Equidistant. Equidistant is kind of made up of two different words, equal and distance. So equidistant means the same distance. All right, so the definition says that it's a set of points that's equidistant from the same point. So that sounds kind of fancy and a little bit confusing, but it's really not. So let me explain it. A set of points. A set of points means more than one point. You got a bunch of points. So you got a bunch of points, and they're all the same distance from the same point. Well, there's a bunch of points. How are those points going to be the same distance from one point? Say I pick my one point over here. Obviously, that point is a lot closer to it than this point. So that set of points is not going to work. It's got to be a specific set of points. Can you even imagine a set of points that are all the same distance from the one given point? Let's start backwards. Let's start with a one given point. Here's our given point, and I want to come up with a bunch of points that are all the same distance from that point. So the first one's easy. I'll just pick a point right here. So that point is, let's say, it's the length of my marker cap from my given point. So I'll just use that as my ruler. So I'll move my marker cap over here. Here's a point that's the same distance. It's a marker cap length away. Here's another one, same distance, a marker cap. All right, and I could do this for an eternity, really. I could keep going round and round, and what I'm going to end up making here, are you seeing this point, are you seeing this shape come into form? This shape is going to be a circle. Now that's kind of not exactly through my points, but you get the gist here. So there you go. What we're working here towards is the definition of a circle. The definition of a circle is a set of points that's equidistant from the same point. All these points on this circle are the same distance from the center. The given point is the center of the circle. That's why when you draw a radius, it doesn't matter if you draw it here, if you draw it there, if you draw it over here, if you draw it to the right. It doesn't matter how you draw your radius. The radius is always the same length because all these points on the circle are the same distance from the center. They're equidistant from that given point. That given point is the center. So as far as circles go, there's a ton of stuff that I could teach you about circles and geometry. And when we get into the third quarter, we're going to have 3 or 4 tests in a row that are just circles. But that's a ways away. For now, it's just the definition of a circle. There's your definition. All right, another shape that you probably think you understand, just like you thought you understood circle, but you probably have never seen it described in that technical way. That's a lot of what this year is going to be like. It's going to be a lot of common shapes, a lot of things that you've already learned that you think you know, but you're going to see them in a more technical aspect, a more precise definition. And one of those things is an angle. All right, an angle can actually be made 3 different ways. It can be made with lines, it can be made with segments, and it can be made with rays. So if you make it with lines, here's a line, it's got an arrow on each end, goes in every direction, or it goes in each direction forever. If you cross that with another line, now you've technically made 4 angles. So let me just label some of these points. Let's say this is X, Y, and Z. So let's say I'm talking about angle Y, X, Z. All right, I've been thinking about these videos. I probably should have showed you this notation earlier this week. I'm not sure if it came up into the do stuff. But basically, if you label an angle with 3 letters, you're talking about the middle letter is the vertex. The vertex is the most important point on an angle. It's where the 2 parts of the angle come together. That's your vertex right there. So the vertex is always the middle letter, and then your end letters are the lines, segments, or rays that extend off that vertex. So angle YXZ is the same thing as angle ZXY. So that's a common question I get. Okay, they say, I understand that the vertex has to be the middle letter, but how do I know what has to be the first and the third letter? It doesn't matter. You could do YXZ or ZXY. You're talking about the same exact angle. One way is not more right than the other. All right, so that's how you label an angle with 3 letters. So if you see a picture like that and it asks you, what is that angle made of? You're going to say it's made of 2 lines. Say you see an angle that looks like this. That angle is made with 2 segments, Y, X, and Z. There's no arrows on that picture. That means those segments aren't extending in any direction forever. They're all ending at X, Y, and Z. So you could say this is points Z and Y with a common endpoint. All right, points X and Y with a common endpoint. That means they're not rays, they're not lines, they're just 3 points that are connected together to form an angle. All right, and then rays. You can make an angle with 2 rays, and it's going to look similar to segments X, Y, Z, but now the segments don't stop at Z and Y. They continue beyond them in that direction forever. So now they're rays. So your definition would be similar to this, points Y and Z, or I'm sorry, Z and Y, Y and Z, whatever, with a common endpoint. but it's going to have a little bit more to that. They're going to say something like rays that extend through Z, a ray that extends through Y, or yeah, I don't know how they would define this without using the word ray, honestly, because you might say something like, well, let's see how they did it. They might say common endpoint, points Z and Y with a common endpoint, but extending beyond Z and Y. So that's a little tedious to write all this out to describe that angle like this. I'm just trying to think of how they might describe it without using the word ray, and there's no easy way to do that. If you're going to make an angle with rays, they're going to say in the definition that it's made with rays. All right, so essentially those are the three ways to make an angle. You can make an angle with lines, you can make an angle with segments, and you can make an angle with rays. All right, they all have one thing in common. They all have a vertex, and they all have two sides to your angle. So every angle has a vertex and two sides. It's just the thing they have in common is the vertex. The thing they might not have in common is the sides, because sides can be made three different ways. You can make sides using two lines, you can make sides using two segments, or you can make the sides of the angle using two rays. So an angle just got a little bit more difficult than what you may have thought an angle meant. Now you have to be more technical. You have to know, is this angle being made with lines, segments, or rays? And there you go. I think you guys are ready for the test now. If you feel confused, we're live every day for 10 minutes. Please come to that session with questions in mind. I think that's going to be the best way to utilize that time is to answer questions. I'll go over a couple more examples, but the videos is really where the learning is going to take place this year. So watch these videos, do the problems that are in the do section, and if you're confused, that's fine. Come to the 10 minutes prepared to ask some questions. We'll do the 10 minutes live before the test. I'm not going to put a bunch of review problems on the board because that'd be kind of like cheating, giving you review problems right before the test. But you can ask questions. So if you're nervous about a test, come to the 10-minute review session before the test with some questions. I'll answer your questions, hopefully lower your anxiety level, get you feeling confident, and then you can take the test.